Hey, good afternoon, everyone. Dan Painter here, Product Training and Development Manager at Flint & Walling, and your host for today's web conference titled Submersible Turbine Pumps. With the conclusion of this conference today, we will have officially reached our halfway point in our winter web conference series. This is the first web conference that we've conducted on submersible turbine pumps. And you might also notice that on the screen is our affiliate Wolfe Customized Pumps. Wolfe is a submersible turbine pump manufacturer located in West Texas that was become part of a Flint & Walling subsidiary a few years back. And so with that, I'd like to give you a little introduction not only to Wolfe, but to the submersible turbine pump lines that are manufactured from that facility. So with that, we'll go ahead and get started. Wolfe is a family-owned business. They started off in 1951, and they're located in Abernathy, Texas, which is just above Lubbock. And the location of that facility there kind of put them squarely in the part of the most abrasive water conditions in West Texas. So they're located in West Texas, and the water conditions in that part of the country, had you ever been there, are not very good. But with that, if you were to talk to someone from Wolfe, they would explain their line pretty easily. They would say that they manufacture basically 6 sizes of submersible turbines. Those are ranging from 4, 5, 6, 7, 8, and 10 inch. Of course, within each of those models are various flow rate demands, so various stages can be built into each one of those size pumps. And the application for these type of pumps are obviously irrigation, a lot of center pivot irrigation applications fall right into the breadth of this product line, along with municipal wells, livestock, mining operations, and saltwater applications. So only 6 sizes, but a multitude of models and an even greater multitude of options, which I'm going to attempt to explain to you some of the various options used in building these submersible turbines. But all that said, given the fact that they are located out there in the western portion of Texas, the life expectancy for a Wolfe pump is on average 15 to 20 years. And to date, we're experiencing less than 0.25% on a warranty return. So very, very successful product that they're putting together there. Long-term, a lot of longevity to the extent most of us here, and I know this is going to come across biased, but most of us here at Flint & Walling and Wolfe would make the statement shown at the bottom of your screen that Wolfe simply will outlast any pump. Now, that's a broad statement, and I guess the question might come into, well, why is that? And that's what I'm going to make a stab at explaining to you here over these next couple dozen slides is, why does a Wolfe pump stay in the hole, and why does it outlast other brands? So with that, I would tell you that and we'll go through these briefly. We're not going to hang on these first few slides very long, but all incoming goods. These can be bowls, mounting brackets, discharges, everything that comes into the Wolfe factory. The first thing that happens is it goes through a quality inspection, and those that pass that inspection are tagged such, and that all takes place before they go into inventory. Additionally, impellers come in, various types of impellers, sizes of impellers, same with shafts. Wolfe manufactures a variety of different pump shafts for applications that I'll explain to you in later slides, along with the bearings and the bushings. So everything that comes in is quality inspected first and then put into inventory. One of the things that Wolfe does, they do machining down there. So here are some samples of some of the raw components as they come in, such as the impellers over on the left side. But they'll machine these with a variety of CNC machines down there, so that once they've been machined, they look more like this. The bowl in the center, there's a raw casting there, and then once it's been machined, it takes on a whole different look, along with pump discharges. These are the top pieces that go onto the top of the pump, and those get machined as well. When it comes to the pump shafts, moving on to the next slide, when these pump shafts come in, one of the first things that we'll do with these shafts is we will straighten them. And I'm going to circle back on this term because it's very, very important to have a shaft that is absolutely true in concentricity, I think it is, but it needs to be straight. The next thing that Wolfe will do is they'll cut those shafts to length for the various horsepower and models pumps. They'll bore them and tap them. And one thing, and I'm not sure this is exclusive to Wolfe, although I've not seen this anywhere else nor heard of it anywhere else, but Wolfe, they'll rack these shafts and they'll stock them vertically. In a minute or two, I'm going to tell you why that is. But these shafts are all hung and stocked in a vertical fashion like you see on your screen there. And of course, all shafts will be re-inspected before use. To circle back on that straightening, like I mentioned earlier, it's very critical that a shaft in a submersible turbine pump be very true, which is why we hang them vertically. After we straighten them and cut them to length, we hang them vertically, because what we want to avoid is any bending or curves or any sags that may occur in those shafts. If shafts are stored horizontally, like plastic lengths of plastic pipe are, there is a tendency, because of the weight and the length of these shafts, that they can experience a little bit of sag. And that's the last thing you're going to want to have happen inside of a submersible turbine, because if you do have any slight bend, very slight bend, or any sag to that shaft at all, you're going to get vibration and you're going to overload the bearings. And so obviously the opposite of that would be true, that if the shaft is in fact straight, it will eliminate that vibration and it will eliminate overloading bearings. In addition to that, it just adds to the longevity of the bushings that you'll see go inside these pumps. So it's very important that shafts remain straight, and for good reason. Eliminates those things that I've got on the screen for you right now. So when it comes to these shafts, like I mentioned before, there are a lot of choices, a lot of options that our customers will have when it comes to shafts. For example, we have shafts that are available out of 416 stainless steel. They're affordable, it's an industry standard, and the fact that it's 416 stainless steel makes it corrosion resistant. We also have shafts made out of 316 stainless steel for even greater corrosion resistance. And then we have shafts that you can get that are 17.4. These type of shafts will be used in applications where there's a high amount of corrosivity to the water or high torque. And in this case, we're talking about pumps on motors of over 250 horsepower. There'll be a lot more torque on those motors than others. Chrome shafts. We have chrome shafts available. This is one of the hardest materials. Again, designed for high abrasives and or particulates. And then we have ion shafts. This is not a coating, so there's no peeling, but with an ion shaft, it's very smooth, very low resistance to corrosion and wear, and provides less friction. So right there are a handful of various shafts that can be used in various applications. And where a lot of these sometimes will get selected is if previous pumps have extremely short life due to improper material for the application. So Wolfe can actually dial into a water quality, whether it's a water quality issue, they can dial in and put the right shaft in that pump so that we get longevity and life out of it, which is one of the reasons why we can expect a 15 to 20 year life expectancy. Additionally, there are an assortment of bushings that go into these submersible turbine pumps. I'll try to outline these for you. The sampling is on the right-hand side of your screen. So if we start off with the bushing in the middle, the rubber bushing. The rubber bushing is what we call fluted. You can see, well, the image is not all that great, but you can see that there are diagonally channels that run down through that bushing inside wall, and that's to allow particulates to be directed through that bearing so that it doesn't damage the shaft and or the bearing. So that's a passageway, very popular bearing used to again, run particulates so that we don't get excessive wear. The bronze bearing, just left to that, that's an industry standard. A lot of times bronze bearings are going to be used just to add that additional strength and stability, especially when you start building up multi-stages. You got 6 or 8 or 10 or 11 stages in that pump. A bronze bearing will add stability throughout that length of that pump end. There's a silicon carbide bearing that can be used, and silicon carbide also is a very hard material and does a great job of protecting against abrasives and particulates. The top bearing at the top there is what's called Vesconite. Vesconite is oftentimes used when we're dealing with high temperatures or chemical resistance. So again, these options that are available in our submersible turbine pumps are there so that we can get the right pump in the right application and have a lot of success with longevity. And then there's a proprietary ceramic bearing. It's in the middle on the far right-hand side. That is a bearing that's proprietary for Wolfe, and it's extremely durable in fine sand or particulate applications because the bearing is a two-piece bearing. One is affixed to the shaft and rotates inside the outer portion of the secondary part of that bearing. And the clearance between those two pieces is only 1/1000th of an inch. So virtually nothing can get through in between that bearing or that shaft with that ceramic bearing in place. To put that in perspective, that 1/1000th inch clearance, a human hair, a single human hair is 4/1000. So that'll give you some idea as to the very close tolerance that we have with that proprietary ceramic bearing. So when it comes to these bushings, just to give you some idea, this image is not the best. I tried to, excuse me, blow this up a little bit, but we put let's call it a test pump into some pretty aggressive particulates and corrosivity, and we put a variety of bearings in there. So if you look at this shaft on the left-hand side of this shaft right there, that's where a rubber bearing was located. So you can see that in this extreme condition, we were getting shaft wear even with that fluted rubber bearing over there, whereas the Vesconite bearing that went on the other end, little if any wear at all. So this is what I'm talking about for water conditions and applications. We can choose options that's going to give us the best chance of putting a pump in that's going to stay in there for a long time. So again, many different types of bushings are available as well. When we move on to impellers, again, Wolfe offers many options when it comes to impellers. The low lead bronze is the industry standard. They're good for chemical resistance. There is also 304 stainless steel. These are investment cast impellers. We'll use those in areas where we have extremely high abrasives or we have to accommodate chemicals of some type, so they're chemical resistance. You can get these impellers in either an opened or an enclosed design, and also Wolfe will custom trim impellers to every 1/16th of an inch. I think the truth be known, they'll trim impellers to where we need them to be trimmed so that we can hit exact design points on the curves for certain applications. So trimming impellers is a very common practice for those that build submersible turbine pumps. And then lastly, to round out some of the impeller options that you have, Wolfe also offers on their 4, 5, and 6-inch size turbine pumps. They'll offer open stainless steel impellers, and that's pretty much a Wolfe exclusive. I don't know of any other company that offers the stainless steel open impeller in those size pumps. Nonetheless, no matter what impeller you choose or what impeller we suggest, all impellers, 100%, will go through a balancing process. And very similar to having a set of new tires put on your truck, you would be quite foolish not to have those tires balanced, because again, a tire that's out of balance is going to create vibration. It's going to, shake, rattle, and roll. And if you do not correct that problem, eventually that vibration that takes place is going to prematurely wear something else out. And so we balance every one of these impellers. The machine that we use to do that with is pictured in the center of your screen. Unlike a tire, when you bring a tire into balance, you typically are going to add weight. But with impellers, it's just the opposite. To bring an impeller into balance, we will remove some material off the backside or the skirt of that impeller. So with an impeller, we'll take weight away to bring it into balance. With a tire, you will add weight. I want to go into the pump here for just a second, because I think this is also important, and that's in the placement of the impellers. Up on your screen, I have a Wolfe impeller that's actually sitting inside of a bowl, pictured on the right, and a competitive model, doesn't matter whose it is, but a competitive model over on the left. And I want to point out a couple differences, particularly in these areas that I've got highlighted here. And I'm going to blow these up just a little bit so we can take a little closer look. But in a submersible turbine pump, it's not uncommon for water to come out under the skirt of the impeller. And so as you can see in the diagram here, I'm going to blow this up a little bit closer so that you can see it. When the water that's coming out from the skirt of the impeller has no place to go because of the placement of the impeller, it's going to create some damage. Whereas you can see the Wolfe has plenty of adequate room for any water that's coming out from underneath there. It has a passageway to move on up through the stack. But the one on the left down there at the bottom, you can see that it almost abruptly runs right into a portion of the casting of the bowl. And let me show you what happens when you run a pump very long with this kind of a placement of the impeller. On your screen now, you can see that water just literally created its own pathway, since it didn't really have one, but it did it at the expense of the bowl. And so it will create grooves around the bowl, as you can see in the image there. We do not want that to happen with our pumps, so we assure that each impeller is placed properly within that bowl and the design of that, so that we're not just running right into a cast iron wall as it exits the bottom of that impeller. So we don't get that kind of a thing going on with a Wolfe bowl because of the placement. When it comes to discharge castings, you've got some choices there as well. These discharge castings are all going to be made out of class 65 ductile iron. Again, when you use ductile iron, you're adding strength. And so with the choices that you have with the discharges, there's what internally at least we call a white top. It's just a discharge. There's no bearing in that discharge. There's no collar in that discharge. It's just an open discharge, as you see pictured on the screen. But we do have some other options. We have what we call a red top, and a red top will include a discharge bearing or collar, as you can see. Most of well, in fact, all of the 4-inch subs that we manufacture here at Flint Walling will all have discharge bearings built into the discharge, but that is an option when you look at submersible turbine pumps. So these bearings can be either closed or sleeved, like you see there. One of the nice things about a closed bearing is it totally eliminates any type of passageway through there. So if no water can go through a closed bearing, obviously, then we're under the impression that the particulates and the fine sands that can be associated in a water supply will not go through that bearing area as well. No water goes through, no sand goes through. We get some longevity out of these discharge bearings. I'll also point out while we're on this topic here real quick that for pumps that are 3 stages or less, Wolfe will oftentimes go ahead and put a factory set upthrust bolt in the top of that discharge to help compensate for any upthrust conditions that may occur. One of Wolfe's greatest strengths, however, I believe, lies within their bowls. And if we look at these bowls that Wolfe offers, you got a couple choices here. One is a glass-lined cast iron bowl. It's actually a vitreous enamel that we put inside the bowl. This is a very, very popular bowl that we offer. It's demanded in a lot of applications. And with that glass lining that's inside the bowl itself, obviously it creates a much smoother passageway for water. If you look at a submersible turbine, it's simply trying to move water through itself as efficiently as it possibly can. And so by putting a glass-lined bowl in there, we reduce any frictions, we increase that efficiency, and as I already mentioned, it's a pretty smooth ride through there. But in addition to the glass-lined cast iron, we also make available the Class 65 Ductile Iron. And again, that's for strength. So when we get into large pumps, multiple stages, many stages, in fact, we may opt to go with the Ductile Iron for the added strength. When using ductile iron, these are good for deep set pumps. And again, deep set pumps are somewhat typical of having multiple stages. Or if they're looking for high pressure, we find that ductile iron is oftentimes used in the mining and oil field applications, along with washdown operations, oftentimes associated with livestock. So the last of our choices on bowls then are the stainless steel. And we will opt to use stainless steel oftentimes in the very, very corrosive atmosphere of saltwater applications and or mining. When we look at these bowls also, I think it's important that we point out there's a difference, we feel, between the threaded bowls and the bolt-together bowls. Most all of Wolfe's sub-turbine bowls are of a threaded design, while many of our competitors use the bolt together. And one thing that I would point out that can occur with a bolt together pump is this next image here. Both of these templates would represent what would be called 6-inch submersible turbine pumps. One's threaded, one's bolt together. What we find on the bolt together is that you can't increase the outside diameter of your pump. It's a 6-inch pump. So in order to get the bolts and allow passageway for those bolts to come through, the flange right there where the bolts go through is got to be relatively more thickness than the comparable threaded bolt. Now, what this ultimately does is it decreases the inside diameter. And as I mentioned a minute or two ago, a pump wants to move water through itself as efficiently and smoothly as possible. So, for example, and again, brands don't matter, but I took a bolt-together bowl apart, and I actually measured the inside diameter, and the results of that measurement come up to 4.625 inches inside diameter. And it's referred to as a 6-inch submersible turbine. But because the threaded bowl doesn't require that additional thickness up there at the top, we're 5¼ inches or 5.125 inches inside diameter. That equates to about a 15% larger ID, inside diameter. So that we find to be an advantage also when it comes to performance and efficiency. So we opt to use threaded bowls as much as possible. If you're actually assembling one of these, they assemble about 5 times faster than a threaded type design, and primarily because everywhere where we're threading a bowl on, the bolt together is going to have multiple bolts put in. So assembly time typically is going to take much longer for a threaded design or for a bolt together design versus a threaded design. In fact, here's an example. It takes less than 30 minutes for us to assemble an 11-stage pump. The one on your screen, the green pump on your screen, is only a 3-stage pump. So, an 11-stage pump will take us about 30 minutes to put together. Comparable, the bolt together pump took over 2 hours because the 11-stage bolt together pump, I think, if I recall, had 96 bolts total that all needed to be put in and tightened down. Kind of like when you put a tire on, you kind of rotate your tightenings so that you can draw this down evenly. But anyway, there's no question that the assembly time and the speed in which a threaded design can be put together is much faster than the bolt together design. And where this is also going to play a role is when we talk about how quickly can we ship these pumps, which I'll come back to in a second. But as I've traveled the country and I talked about the advantages of what I believe to be the threaded bowl over the bolt together bowl, this is a comment that I've had made to me on multiple occasions. I'll have a contractor tell me, well, I don't like the threaded bowls because, once this pump's been installed for several years, I can't get it apart when I pull it out of a well. I can't take it apart. The threads have all seized together, and where they're bolt together, I can unbolt those things and I can get that pump apart. Well, I understand this comment. I don't debate this comment only unless they're making the comment against a Wolfe pump, because with a Wolfe pump, that's not the case at all. And I want to show you why. I want to show you why inside. And so we're going to take a closer look inside this bowl. But Wolfe has what we call concealed threads and watertight flanges. I've kind of got it highlighted over there on the left-hand side, where you can see that where one bowl is mating up with another. Here's a little closer look, so you can see the male threads in there. You see the female threads, the engagement between the two, and of course where the two flange pieces come together, that literally forms a watertight seal right at that point. Yet a little closer look, when we talk about this thread engagement, this thread design, the mating flanges down there on the bowls, like I mentioned, provides a watertight seal irrespective of the threads. When those bowls go together, that forms a watertight seal. What we'll do with those male threads, and this is on every single bowl, folks, this is on every single bowl, we will chamfer at the top. We'll chamfer those threads at the top. That eliminates any burrs or any thin starting threads. And I think most of you probably know what I'm talking about. We've all seen and experienced the challenges that very thin starting threads can have, or any burrs up there at the top. Another thing is that the female threads do not start at the top, and they run much deeper than the male threads, as you can see in this image. So the bottom line is this: you put a Wolfe pump in a well, that water is not coming in contact with the thread engagement, which is the reason why I mentioned in the previous slide that when somebody says, well, I can't get the threaded bowls apart, that's not true with Wolfe, because we're not putting water into the area where the threads are engaged. In fact, I think but a year or so ago, on a trip down to Wolfe, we actually disassembled a 25-year-old Wolfe pump that had laid out in a scrapyard for I don't know how many years, but that pump come apart in a few minutes. The gentleman that you see there, all he had to do is just he hit it with a hammer in a few spots, but I would tell you that no heat was required, and put a strap wrench on there and those bowls, as you can see, come right off. And again, that was probably less than the whole from start to finish. I think within 15 or 20 minutes, we had that pump completely apart. I mentioned that bowls were a strength for Wolfe, and these are some of the reasons why. Another strength that I believe you get with a Wolfe bowl is the bowl thickness. Now here's a couple of examples, Wolfe being on the left, a competitive model on the right. So this is a cross section of the bowl, and as you can see, we have a much greater thickness, much more robust wall thickness than many of our competitors would have. So these are some of the reasons why a Wolfe pump is able to withstand some of the conditions where another pump may not have much longevity out of it. So when it comes to these bowls, again, just as a little recap here, when it comes to the bowls, you've got a choice. In construction, material of construction, you can either get that vitreous enamel glass lined bowl, or you can use a ductile iron bowl if strength is needed. As I've mentioned, we've got large inside diameters, up to 15% larger than a comparable bowl from another pump. And the assembly time and disassembly time, we win in both those categories because these bowls do come apart. Obviously, they can be unthreaded and disassembled in much faster fashion than to take all the bolts out of a bolt-together pump. And in fact, you can literally spin these bowls with your fingers. That's how good this thread engagement is on these threaded bowls. And a robust and heavier wall thickness. So we've talked about impellers, we've talked about bushings, we've talked about discharges and bowls and shafts, just to give you an idea of what makes up a submersible turbine pump. And then the thing I want to kind of leave you on here is the testing. Every one of these pumps are going to be 100% factory tested. And in fact, Wolfe has a state-of-the-art test facility down there, and they will wet test every pump, whether you're buying it with a motor or not. They're going to wet test every pump up to 500 horsepower before it leaves the factory. Wolfe has a very large tower that is above this test facility, so we can test. I'm going to give you an idea of what all we can test. We test for on any given pump. We'll test for 100 feet above the design point. We'll test that pump at the design point or points. We'll test it for 100 feet below the design point, and we'll test it at shutoff. So we get a very thorough curve on that pump to make sure we're hitting the design points that your application calls for. And as I mentioned, that Wolfe has a very, very large tower. I think this thing's, 65 or 70 feet tall, because some of the pumps that we're going to put in here are quite long in length. Because we can, so we got a 70,000 gallon test pit down there, two 60-inch casings that go 85 feet deep. And then we can test on pipe sizes 2 through 10 inch and up to about 800 gallons per minute or 8,000 gallons per minute. Couple things before we close this introductory web conference off just on these Wolfe turbines. And I don't have them on the slides, but Wolfe has a digital camera 360 degrees in that test facility. And that sometimes is used for our customers to be able to, in real time, see their pumps get tested, and they can see the results of those tests. And so there's an observation tower down there. Sometimes customers come in and they actually can watch their pump being built and watch the test results as it takes place. So, little introduction today on Wolfe. As we go into future web conferences, we're going to dial into some more specifics when it comes to sizing. troubleshooting, these type of submersible turbine pumps. But again, our facility is located in West Texas. Because of the speed of these pumps, the assembly time, this is what our delivery looks like. So shipping out of West Texas, you can see that most parts of the country are in a 1 to 2 day delivery. So these pumps ship very quick. Sometimes if we get an order by, say, 10 o'clock Central Standard Time, that pump can be built, tested, painted, boxed, and shipped before that day's out. So again, 1 to 2 days of delivery suffices for most of the country. I appreciate you joining me today. Again, these web conferences rarely last a full hour. And so with that, I'm going to close this one out. Hope that you understand a little bit more about our Wolfe submersible turbines, the options that are available, some of the features and strengths that I believe we possess in the marketplace. And so with that, I'm going to go ahead and close this out. And I appreciate you sitting in on this today. If you travel this weekend, travel safely. We need you all. And so with that, I'll bid you farewell until next time. This conference has ended. Thank you very much.